So our next speaker is Professor Syed Husain, and he is going to talk about complex system dynamics and Wick's problem.
All right, thank you. So first of all, I thank the organizer for this wonderful opportunity. Uh, my research broadly overlaps with complex systems dynamics, with data-driven approaches and intersects with social system as well. So I'll be speaking about some wicked problems, and then we are bringing some cognition aspect into that, but I won't go into that. I will discuss about some of my recent work, not exactly all of the research work, but some lessons and some insights from my research work. Right, so this is just an analogy, so, or we can say the evolution of physics as well. So there is a time when we used to have a reductionist thought in the world of physics, uh, reductionist thought, linear thinking, and later on we are with systems thinking and systems perspective. So over the time, the interdisciplinarity is coming out, and then disciplinary boundary is diminishing, and then we have a more broader perspective on different types of aspect. And then we have non-linearity, self-organization, interaction within the system, outside the systems, and open system or closed system. So this is how this story or philosophical story from India tells about this. So, okay, so now coming to the wicked problems are problems that are considered as a problem that has no definitive solution, or over the time, the solution may vary. So here we can bring the aspect of contextuality, non-locality, and bring the quantum cognition perspective, which is like non-binary logic. This is an upcoming work, so I won't go into the details of this non-locality and non-binary logic, but this is a type of systems where we have wicked problem that affects in short term as well as long terms consequences are there. So these are characterized by the complexity and the interconnectedness, where the actors are interconnected with each other. It may include the social fabrics, cultural fabric, or natural issues, and the intermingling. As of now, we are having society and AI and the interface. There is a lot of debate going on. So we have physics-inspired thinking, which is polyfocal worldview, and statistical mechanics-based approach, which employs the aspect of network science and random matrices to understand some of the data-driven scores and what exactly the problems are. So to get more deeper insight, I'll just go to that. So these are some of the wicked policy problems. Those were the definition. This is the case of digital populism. Initially, we have an information revolution. We have a lot of information. Now we are becoming a keyboard warrior. There's an increasing polarization across the world. So short-term effects were there, and now long-term consequences are there, which is a feedback loop in the backfire. Second is the Great Atlantic Pacific garbage patch, where we carelessly throw the plastic. Those goes along the gyres, which is 5 gyres across the world oceanic system that maintain the salinity, temperature, nutrients. But nowadays, the circulation is with the plastic, nylon fibers, and brush, and so on. So this is more than the size of Texas, Great Pacific Garbage Patch. Now people are getting aware of it and they are working to clear it, but it's still a wicked problem. Initially, we didn't care. Now it's a huge problem. Third is the group dynamics in financial markets. Second is like short-term benefit and long-term consequences in ecology, which is like sand tars, extracting petroleum from sand tars and affecting the ecology and biodiversity loss. Next slide would be about this, new decision sciences for complex system, which is where we have the idea of network science. We have hubs, we have uh, more information, we can have information update on the system, and this information update can give a best scenario based insight through agent based modeling or network science approaches. The same is with this biodiversity loss, habitat loss, and then again long-term consequences. Somebody was speaking about mucus. We have silicosis. The people who are working in the extraction for semiconductor devices, we are going into the semiconductor revolution for AI thing. But again, working and extracting these minerals affecting our health, and then we have these long-term consequences. So these are wicked policy problems where we have short-term benefits, long-term consequences, collapse of East Coast fisheries, and so on. So just leaving it. Now coming to the aspect of these vocabulary, bringing from the complexity towards a social system, or let's say higher dimensional system with computational social sciences approach. We have non-equilibrium because the system always evolves. We have definitive interactions with within the system, outside the system, non-linearity. This non-linearity drive the system, and feedback loops, positive, negative, and so on. So this is the data from World Happiness Report, where you can see the happiness score. 7 score is performing countries, but again, going back to the series, which is happiness score, top countries, how about the countries that are not performing well? So we can see the countries that are not performing well are in the region of Africa, South America, Middle East, and so on. Okay, so we checked 2015, 2018, 2017, and so on. The top, the bottommost actors or the bottommost countries, and these are some of the bottommost countries. Surprisingly, these are the countries that are affected by climate change, that are also affected by conflicts, and that are also rich in some mineral resources. So we can say we have Congo for cobalt required for EV, graphene in Sri Lanka, again conflict is there. Third is lithium triangle in South America. Then the processing of that mineral resources, this is one of our ongoing work, mineral resources processing, and then who is processing, which is like international relation. If China is processing, again, it can weaponize that. But then I went to another data source, that is conflict data and global terrorism data from University of Maryland. And after taking that data, I constructed a time series, that's a short time series, first to see the conflicts and then later on to see the network perspective. So surprisingly, first I used random matrices on the correlation score of the time series. Then I gave a nonlinear distortion, epsilon 0.06. After giving that distortion in the random matrices, I constructed a multidimensional graph with this, and the countries are like this. So if you go back, so these are the countries affected from World Happiness Report. And now, global terrorism database, you can see the countries affected: Afghanistan, Nigeria, Yemen, Syria, Iraq, Somalia, and so on. So this is again the cross verification from a different type of data source by using random matrices, application, and multidimensional scaling. Second, later on, I developed the 46 years of data. I mean, I curated the data from University of Maryland for the 46 years time span and constructed this network. This is the network of terrorist organization and the people who are attacked, organization who are attacked. When police is involved, it is again attacked. When military is involved, it is attacked. So these are the targets. Sources are different types of terrorist organization like Boko Haram, Shining Path, Al-Qaeda, and so on. Again, we have 109 definition of terrorism, uh, declaring the complexity of the subject, but still most of the common component of them are political objective, spread of violence, or a certain specific motive. So you can see the periphery where 8% of the data is there, that is source and target, but 92% of my data is at the center, which is the giant component of this network. In this giant component, you can see the red colored structure, which is identified by using the algorithm of proposed by Vespianani, Alessandro Vespianani, and this is to identify the backbone of this giant component. When I identified the backbone of this giant component, it looks like this for the 46 years. I did for 10 years as well, but we have time constraints, so I just showed this graph. We also did the resilience analysis of this network, and then we came for some policy suggestion that based upon the degree of the network or the degree of the organization, we can identify some of the most notorious organization in order to eliminate that, or with the help of probability distribution function. Amongst many cases, we have the case of Indian subcontinent where we can see the conflicts or the terrorist activities were being shifted from the northern part towards the southeastern part of the India. And then you can see in the Afghanistan and the Pakistan region, there is a growing activities of these conflict and terrorist activities because so then I have another work with Professor Joseph Wittmeyer and Professor Chakrabarty. In this, we have proposed one model, which is innovation diffusion. Innovation diffusion is widely studied, but in this work, we have introduced migration. So in this work, we have introduced migration for the first time, where we have how the presence of a group influence the use of any cultural or technological or policy perspective practice in another group in heterogeneous population. So that means there are two groups. One group is there, I am doing some practice, cultural practice, or I'm using an Android or mobile or iPhone or something like that. And then another group sees me, and then they stop using that particular thing, move towards the higher version of that. We did this with the help of consumer barometer data and on a lattice-based model. And Volcker-Pacala equation into consideration, where the migration term is there, Q21, N22, from the second group to the first group. So these are the result where one group adopt the particular practice, the second group started suppressing down. I'll skip this part because I think I would be running out of time. Thanks a lot for your attention. I would be happy to discuss about this work in detail as well.
Thank you, sir. We will take one or two questions. So there are no questions. Thank you, sir.
Thank you.